Hi, good afternoon. My name is Murugasamy Nachimuthu, Sami Nachimuthu. I go by Sami. And also here we have Panos here. Actually, both of us co-lead the CSM work group, Cloud Service Model work group. And actually, there's a presentation is developed by Nirav, Jim, and Scott, but they were not able to make it, so we are going to present it for them. Today's talk is about life cycle management at scale. I'm just going to give an overview, and I have another presentation to do, so I'm going to leave, and Panos will cover the rest of the presentation. The cloud service model was started about three and a half years back, part of the future technology initiatives. And the goal of that particular work stream is to look at anything that you want to deploy at scale. You want to solve the scale problem. So we were previously looking at doing a telemetry at a scale, data center level. How do you manage the telemetry? How do you look at put the data together? And as part of this, we were also looking at life cycle for a couple of more than 2 or 3 years now. And last 6 months, we spent a lot of efforts to create what are the next things that we can document so that we can create some models to represent life cycle management. So basically, like a lot of work is going in. Please join the work group. And the basic thing is we want to define it such a way it can be represented for any compute systems or however you want to operate in your data center. There is multiple phases. Panos will walk through that. Go ahead, Panos.
Okay, thank you. So, as said, the work stream has started from getting a problem that is solved in one dimension and trying to think of the different dimension that this problem manifests. And for that, like one of the problems is scale. But now we also have I saw to my surprise that several talks and keynotes yesterday were devoted to life cycle and how do you represent what happens to your data center or the server, so the equipment of the data server across the whole, all these phases of a life cycle. And what is a life cycle? We can say in time that there is some phases that we can identify, like planning for the building, planning for the servers, planning for the equipment and the facilities, procuring it, getting in touch with the supply chain, with our vendors, with like doing all the market research that's needed, so the deals needed. Then there is, of course, this big operation phase where all this equipment, all this investment is returning back to you. But that doesn't stop there. There is like some phase that you need to change your equipment or stop doing that, and you need to decommission, and that's also some effort that needs to be taken into account. And that's like the time scale, but also there is factors that all intervene twin together to put some extra challenges, like the real estate factor, the utilities that you need to have planned for, network and system sourcing. How do you plan your configuration? You don't just like procure some system, land them in the data center and think about configuration later. You must have planned for that. You need to reduce your time to market, so all of that needs to be very well prepared. Also now, as it stands, like the industry wants to get certification. You need to get certification for your operation phase. You need to get certification for your carbon emissions, for example, for your safety of your data center, for risk management. There's so much that I cannot even mention everything here. Then, in the deployment and operational phase, you start worrying about your orchestration. How do you put all that together? How do you measure your utilization and make sure that what you have paid, what you have procured, what you have planned is what will be returning on your investment at the maximum possible rate, of course. But it just doesn't work. You will have faults. You need to detect the faults for one, like they don't like speak for themselves. So you need to detect them and initiate a repair procedure that needs to be taken into account. All of that. I will just jump to the other column that the industry is not, that's what I say is not new to the industry. There is already standards. There is already other initiatives within OCP, other companies that have been working on products on these domains. But what we have identified as a working group is the combination of all these factors, talking about the top-down, the big picture, is something that we have not seen being addressed in a very clear, very standardized way yet. So also, we should not forget about scale. We're not talking about a single rack. Sometimes we mention a rack, we describe a rack, we bring the problem down to a single rack to say how it manifests, but once we have many of them, like the tens of thousands, hundreds of thousands, what is it? And when we distribute racks across locations, across domains, across time zones, we need to operate all these problems, all these factors that I mentioned on the scale of the population of these racks. So it does not it's not easy, it's not just a simple multiplication that you will solve one rack, you multiply it, 100,000, it will just work. It gets more difficult. Of course, you will need to aggregate and think of the problems, how do you scale the problems, how do you assess the problems on that scale. Even the life cycle that I mentioned before, the time phases are not separate from each other. You do have interconnect, you do have a spillover of one phase into the other, or problems that may jump back and forth between the phases. For example, you're planning for some equipment, let's talk about servers alone. You're planning for that equipment, but the supply chain cannot guarantee 100% delivery of them. You may run into some supply chain or under delivery or any other issues with transportation of servers. So that's not a solved problem. You may need to go back. You may arrive at the data center and find that some of the systems are not usable out of the box, have some faults like dead on arrival, or some misconfigurations, or some faulty hardware or something that you need to identify and repair. So there is some leak there, some less than 100% yield of what you have planned for. And then in the operation phase, you also come into the same problem that you will need during the return of investment phase, as I call it. You will still need to service things, procure spare parts, think about the availability of spare parts, redo your exercise of what you need to get. And at the same time, while you're operating, you may have started the decommission, or you may be running decommission of other hardware inside the same data center, or repurposing some part of your data center for a different workload. I can mention AI for one that goes everywhere. So in all that, I have slides for 4 specific examples. I will take mostly one of them. It's there's not enough time to expand on all of those. And so how deep we can go with each one of them. Like utilization, I had a very nice talk yesterday about the stale capacity, the stranded capacity that you may have on your data center. And I would add to that, that's not only on your operational phase. Your stranded capacity will span all through the other stages and will be linked with all the other factors, or several of the other factors that we mentioned before. For example, you need to plan for more capacity that you will need. You will need to plan for a bigger building, or some extra power, or some extra network, so that you don't arrive at the operational phase having a lack of that and being that a bottleneck. So that's something you need to think of back and forth, so how much you're over-provisioning and how much you can utilize that over-provisioned capacity that you may have, then, or your procurement and deploy, how do you plan for some redundancy of vendors, have some redundancy of equipment that you will have available. You know, it may be you need to procure more, like, let's say, network cards or network cables than your nominal 100% capacity. All of that, and be able to identify and justify what is your the capacity that you have on your spare storage versus what is returning on investment. Modeling that now becomes an exercise. I have not seen many tools, you know, except for some proprietary tools that we use in very large scales. We have not seen industry standards tools for doing that, and this is what we identify as a gap in the market, right? Now, with decommissioning, you will need to think about what is the capacity that's being decommissioned and what other utilities, what other resources it brings down with it, right? And for that, like, if we were to build a model, we will need to be measuring all these factors to accurately model and measure the utilization across phases or even on just the operation phase. So all of these factors are examples. They're not fully blown, and as a work group, we're trying to identify, at least put them in the map, list them as a mental exercise to see if a system can cover them or not. Our goal is not to go and solve each one of them as a narrow item, but our goal is to have a full view that somebody can take and make it a product or make it a consideration, a guidance for operators to know what they're doing. And for that, we may spill over the experience we have from large installation for hyperscale into some other players on the market, because OCP is all about collaboration. It's all about sharing our experiences and take it to other domains, or, you know, across the big ones, say. So also, like, you know, my other slides, or the slides of Nirav and Scott and Jim, is like we'll be talking about health status. How does the health manifest in different stages? How is it measured, and how this, like the health of individual system or health of clusters will affect the overall capacity, the overall planning of the data center. Examples of how the classification of errors will matter when we're doing this exercise. It was mentioned yesterday that sometimes it's like the earlier days of accounting, that we could have measured the same thing in so many different ways. Let's say about like carbon emissions. If you have unhealthy hardware, does it consume power that will direct into carbon emission? How we can reduce that, for example, but having an accurate specification, modeling of the faulty components or the faulty hotspots in our data center in order to represent that in our carbon emission model is not a solved exercise, because we can measure the power. How does like this power distribute into healthy or unhealthy systems? I can make so many examples out of that, like configuration. How do you plan for that? How do you bring it in your life cycle? I will not expand everything. I want to give any seconds back for questions. I think like the time is running out. So in summary, we can, you know, all of us agree that data centers are growing. We're in a scale that every little thing matters because it multiplies so much. We have unique challenges across the domain of time, across the domain of scale, across the domain of complexity to solve. But we still need to make the big picture and have a very sophisticated top-down model that will be able to analyze into all these dimensions and cover them and bring them to a common stage where we can run our data exercises, we can run our modeling and obtain some useful numbers, some useful metrics. We want the industry to come back to us and help us identify all these domains, identify these samples so that we can all work towards, like, ideally a common model. We aim to publish a white paper by the OCP Global Summit this October with our work so far and call the members to participate and give us their feedback or their contributions into building that. Hopefully we should also have like ready products that integrate with that, and more than one is always better. So thank you, and I will take any questions if we have any time.